Okay, final day of the competition, final few hours of the competition. Here talking to Team Purdue EAFIT. What's going on?
Well, we've got our 2 applications that we're working on today. We're finished up with our third application, our known application beforehand, which was lamps. And now they've kind of thrown some mystery goal or mission.
A little mystery curveball.
Yeah, and the mission is basically with PIFR, try to get the lowest power consumption while performing a test in PIFR.
So one data set.
One data set.
With a time limit, I'm sure.
With a time limit, yes. It starts, we have about an hour, 45 minutes to run the entire application. And if we don't get it done in the 45 minutes, of course that's bad. Yeah, that's
okay.
Not something we really don't want.
No, don't want that.
Yeah. So it's a lot of determining hardware configuration, seeing what is going to give us, the most flops per watt. Basically, we're going to try to see how fast we can get it, but also, get it within the 45-minute time frame, but also make sure that we're not using any watts
then
at
start
all.
to minimize hardware from that.
And of course, we have to make sure that the data sets, they function well either with GPUs or CPUs. We need to find out also which, how the data set works in the first place. Otherwise, we'll just be doing everything the wrong way.
There are GPU versions of PIFR, right?
Mm-hmm.
And does the data set make a difference as to whether you use the CPU or the GPU version?
They sometimes can vary. Sometimes the effectiveness of the GPUs, depending on how it's rendered or how they go through, how they process the data. Once in a while, you might get a test case that GPUs may not be giving you as much power and much
but that can vary
efficiency.
by the data set.
Yes, it can vary by the data set. Just it has some variance in that point.
That's interesting.
So we have to kind of figure out, which configuration, more CPUs, less CPUs, more GPUs,
more
less
nodes,
GPUs.
less nodes.
Definitely, and so we're going to be going through all the possible configurations.
In a big hurry too.
Yeah, and so we have from 1 to 3.
3, I think.
Yeah, to basically find what configuration, change the hardware configuration, do what we need to do.
So you have to lock down your new configuration by 3.
Yes.
Okay.
Yeah. And once that's done, we just hands off, run the test. We can't change any more hardware, and we get one run. And so we see how that goes.
Whew. All the marbles.
Yeah, definitely.
Wow, that's impressive. What have you gotten out of the competition?
Well, there's a lot of things that I think this competition has kind of given me, and then the entire conference as a whole. It's a lot of experience kind of, this is my first time going to the competition, and so just kind of figuring out, how to allocate your time. Time management is huge. You want to make sure you have a plan before going into anything, and figuring out, with this one static piece of hardware, basically once you set it up, you have to figure out how can we get the most out of something, and it's a lot of just kind of wrapping your mind around, optimization. How can we get the best out of our applications? How can we get the best with the test cases that are provided? And at the same time, it kind of gives you insight into, real world application, definitely, because, you might, a lot of times, for data processing for scientific purposes or anything like that, they're going to want to optimize everything as well. So, as a matter of days or hours or even minutes, you want to fine tune that so you can get the most out of that.
Absolutely.
Yeah.
Good. So it sounds like you have a lot more confidence.
Oh, yeah.
Excellent. Great. Well, good luck the rest of today. And
thank you.
We'll see what happens.
Yeah.